Okay, see Lindelof. So we're going to solve this triangle ABC, and we are going to use law of cosines to solve this triangle. So here we go. Let's actually try to get straight after this. So this is what I'm going to do here. I think, let me see what my notes say I was going to do first. I guess I'm going to solve for side A first. So A equals some amount. So we say that I'm just going to use this rule that we know, which is that A squared is equal to B squared plus C squared minus 2 times BC cosine of A. Now we're just going to but we're going to fill in the blanks and see what we end up with here. So A squared equals B squared. So if this is angle beta, then this is side B, so B equals 20. So we have 20 squared plus, if this is C, then straight out from there, right? Straight out to there is side C, so that's 30, so 30 squared minus 2 times 20 times 30 cosine, and we want cosine A, and A is 60 degrees, so 60 degrees is our A squared. When we do this math, we get, 400 plus 900 minus, is it 1200? Minus 1200 times cosine 60. This is a good one because we know that cosine of 60 degrees is equal to 1/2. If you're a trig student, you should know that, right? It's right off the unit circle. So it's 1/2. So this should get a little easier for us. Excuse me, equals A squared. And half of this is negative 600. If 600, this together is 1300. 1300 minus 600 is 700. So A squared is equal to 700. Therefore, take the square root of both sides, and we get A is approximately equal to 26. This is the square root of 700. So it's 26, and it's 26 and change. You ask your professor how he or she wants you to do that math, but I'm going to put 26 there. So what does that leave us with? We have all of our sides now. We have this side of 30, which was given to us, this side of 20, which was given to us, and we have this 60 degrees here. So I think we need these angular values. So there's an argument to be made for how we're going to do this, but because we're working on law of cosines, I'm going to follow law of cosines here, and I'm going to do that. I'm going to look for this angular value here, this angle here that corresponds with side C is usually called gamma. So we're going to take, right, I'm going to go across from that and say that 30 squared is equal to 26 squared plus 20 squared minus 2 times 20 times 26 cosine gamma. C, I'm going to say this again, vertex C usually, because we know that in Greek it's alpha, beta, gamma, therefore C corresponds to the Greek letter gamma, so I'm going to call that gamma if you don't mind. And the way I draw my gamma is this way. I just draw it out like that, and I just pull a little branch off to the side, and hopefully you're buying that as gamma. So I'm going to do my math here. This is 900. 26 squared is 676 plus 400 minus, if you do this multiplication, this is calculator math, just so I have it set, is cosine gamma. Cosine gamma. Add all this crap together and subtract it from this side, and it's 1,000. Isn't it 1,076? So 1,076, so minus 1,076 from both sides gets rid of that, and that gives us negative 176 equals negative 1,400 cosine gamma. Keep moving, and going to divide both sides by negative, right? We can't subtract this out, right? Because this is being multiplied, so we have to divide it out, just to keep that in mind, right? If you stay with me at the end of the video, I'm going to show you how to do some of this math on your calculator, on your ti-nspire CAS. I hope that's helpful to you. Again, this gives me, these cancel out, these negatives cancel out to a positive. And again, I put this in the calculator and I got out this. And the more precise you get this, the better answer you're going to get. So I drag this thing way out, right? Equals cosine gamma. So remember, if that's true, now you're saying what angular value has a cosine that's this? So the other way to ask that question is to say that gamma would be equal to the inverse, right? Arc cosine of this value, which is, and let me show you really quick how to do this. So I'm going to go here. You know what? While we're here, let's skip over to our calculator really, really quickly. And so I just can show you where that is. So I'm just going to skip over to the calculator. You can see I was working on some of that stuff over here. So what I'm going to do is this. I'm going to go to trig, and then I'm going to choose this, right? And here is, I didn't want sine, I wanted cosine, so I can get rid of that. Go back into trig, inverse cosine of, and the number I got was 0.169231. Hit enter. About 80 degrees. If you cut a bunch of this crap off, and that's what I've seen people doing, cutting it off, you're going to get you could get some angular value that's about 79. So it's really close depending on how you round. But I'm going to call this 80 degrees if you don't mind, because this is not going to be perfect. So I'm going to go back to that and say that that is equal to, so gamma, the angle gamma is equal to about 80 degrees. And I have to be careful that we write this to our professor in a way that he or she can stand it. So I'm going to call that an approximation. And that gives us 80 degrees here. Well, if this is 60 and this is 80, we know that from triangle sum theorem that the sum of the interior angles has to be 180, so the remaining angle has to be 180 minus our 60 degrees and our 80 degrees together. And I think that gives us, what is this together? 140. So gives us 40 degrees. So we have a final angular value here of beta of 40 degrees. All right? So I hope that was helpful. I hope you followed along, and I know that I'm going to hear from you because I'm looking forward to it. That, hey, why didn't you use law of sines? Hey, well, could you use law of sines, and how do you know which one to use? And I want to hear from you on that, and hopefully I'll keep exploring this geometry thing. I haven't been doing a lot of it. I've been really busy with the calc, but I'm kind of liking this as a way to explore math. So if you haven't already subscribed, please do. And also, your comments are always welcome. Thanks.